Hello, my name is Angel Sanchez and I'm a data analyst in South Florida. A goal I've set for myself is to teach myself machine learning, and with these videos I'm documenting my journey on learning machine learning. And if you want to follow along with these tutorials, you can find all the code. I'm going to make repositories for them so you can view them and make any changes you'd like to them and see if they can help you. I'm using an introduction to statistical learning with applications in R for the concepts and the theory of machine learning, but I'm using a Jupyter Notebook and I'm using Python. You can use R, you can use whichever tool you prefer. And what I'm going to try to do is I'm going to go and cover the basic topics. More importantly, there's figures in the text that I'm going to recreate, and then I'm just going to explain the significance of those figures. I'm not going to go into any heavy detail. I'm just learning this as you're learning it. So now that we've gotten that out of the way, all of the data sets will be posted in the description, and all the information you need to use them will be posted there as well. Alright, so we're going to start by importing our usual libraries that we would always use in a data science setting. NumPy, pandas, matplotlib, and I like to use Seaborn and matplotlib interchangeably, whichever one works. I usually just look up how to do whatever visualization I'm looking at, and I don't really have an allegiance to a certain thing. I kind of just, whatever works, I'll just continue to do it. Now we're going to work with a wage data set, and I've put all of the files of the data set in the folder that I'm using. You can make another folder with different assets, that's up to you, but that's how I'm doing it, just to make it a little bit more easier for me. And we're using this wage data. We're going to recreate the figures in chapter 1 of this textbook. So let's just have a glimpse of what our data looks like so far. There's a lot wrong with it so far, but we're just going to clean what we're going to use. You would probably want to clean all of this data and encode it so that it's just numbers. But first we're going to get rid of this column here because we don't actually end up using it. So take your data set, and we're going to drop, and we want to take off the correct index, so we put 1 here. Just get another glimpse of what we have so far, and we've removed that column. There is a data dictionary describing all of the columns. It's kind of self-explanatory. You can see that's health insurance, education, wage, etc. But we're going to rename the columns just to make it more clear. So wage.columns equals, that should work. Okay, let's get another glimpse of that. We should see these change. You can see marital status. Should probably have consistency in how you name them, but this is just to show you that sometimes you want to change the column names. We're actually going to be using the wage as our dependent variable and education, age, and year as our independent variables. The only one that needs to be really cleaned in this specific instance is education. You can see that it's a bunch of strings. We just want the numbers. So I want to get all the unique values of that column, and I also want to sort them by numerical order. So we're going to sort them first. We're going to take our wage data and specify what column we're using. So education, and then unique. And so this gives us the unique values, and then also sorts it. So obviously it's 1, 2, 3, 4, 5. It's in order. So now we can change the actual column because we have the values that we want to specify. So we're going to replace the values with integers. So dot replace. And you can just simply copy and paste this. Copy and paste this. Now, after you have the values that you want to change, then you're going to specify what you want to change them to. 1, 2, 3, 4, 5. And now, take another glimpse at our data. See, we should really be doing this for each of the columns, and so you can see education has numbers now. That's what we want in this instance, and we'll keep it that way. You're more than welcome to find any other insights in this data set But for the purpose of this video, we're going to focus on the figures in the textbook. Now in chapter 1, figure 1.1, there's a scatter plot, there's two scatter plots and a box and whisker plot. And I'm going to recreate them instead of in R, I'm going to recreate them in Python. So we'll start with our frame of the plots. We'll use subplots. And we want to define how many specific visualizations we want. So we want 3. And now we get to specify the size. You can make it whatever size you want. This seems to work for me. And you're more than welcome to go in this code and play around with it. That's the whole point of this. So that should give us our, yes, okay. We have our little subplots here, and now we're going to create the first scatter plot. This is the one with wages and age, and we're going to use seaborn. We're going to use a reg plot, which is a regression plot. Our independent variable will be age, so x will equal wage, and then the column specified as age. And for all of these visualizations, we're going to be comparing all these values to wage. So our y's will always be wage. And we'll just see what's created here so far. So it's on this side. I want it to be here. We'll add this to show that I want it to be placed on the leftmost side. And this doesn't really tell us much because first of all, it's all the same color and it's a straight linear line. We kind of want to fit the data onto the scatter plot. So we'll do a couple things. We'll change the color first of the scatter plots, of the actual dots. And we'll do this with scatter underscore KWS. And we'll make the color gray. And so that seems to be, it looks more defined. You can tell the difference between things. But it's still not quite how the visualization is in the text for figure 1.1. So I'm going to change the color of the line to make it a deeper blue. And so we'll do this by using line underscore KWS. Color blue. And that looks as close as we can get, but there's something else I want to do. I want to fit, instead of having a line, a linear regression applied to this, I want to fit the line to the data, make it non-linear. So the way you do this is you use LOESS or low ESS, and that fits the data to the line. Set it to true. And now we have a curve to this visualization, which is what we want. We're going to make the second line chart, which is going to be way easier. Just stipulate that this is the second chart. We're just going to change our independent variable to year instead. Also remove the LOESS from it. Low ESS. I'm not trying to say that right. And then we have a straight line. And now we want to create our box and whisker chart. So we're going to use seaborn SNS box plot, and just to save some time, copy and paste this. And now we're looking at education, which is the column we cleaned earlier. And because we made them in order, it knows to put them in that exact order as well. And this is pretty similar to the figure that we see in the textbook. So I'm just going to explain a little bit the significance, the reason for this data. It's based on factors of wages of a group of males from the Atlantic region of the United States. And the reason for the analysis is to illustrate the potential of regression. By combining age, education, and year, it's basically showing that you can predict a given man's wage by understanding the relationship between those factors. So, for example, in this visualization, wage versus age, as the age increases, the wage increases, and then when you get to 60, it starts to drop off. And so that's just saying you can put on a given age and predict how much the wage will be for that person's age group. For wage versus year, it looks at an area of time between 2003 and 2009. And as the years go up, there's an increase of wages by approximately 10,000 in a linear fashion. And then for the wage versus education box and whisker plot, this shows us that having a lower education tends to indicate a lower wage, and having a higher education tends to indicate a higher wage. Again, this is just to illustrate the power of regression, basically showing how you can predict a number in a group or a set or a time frame. That should be it for this part of the session. In the next video, we're going to cover stock market data and go over classification.